By the end of this lesson, you should be able to identify variables in a given situation, identify a question suitable for scientific investigation, form a hypothesis, design and carry out a simple experiment to test the hypothesis, record and present data in a suitable form, interpret data to draw a conclusion, write a report of the investigation. Swing B seems to move faster. I wonder why. The girls are about the same weight. So, what would cause swing B to move faster? How is swing A different from swing B? Aha! The lengths of the swings are different. Maybe swing B moves faster because it is shorter than swing A. How can you find out if this statement is true? From the observation, we inferred that the length of the swing affects how fast it swings. We can carry out an experiment to find out if this statement is true. To test this, you need something to represent the swing. You need to design an experiment. We want to know if the length of a swing affects how fast it swings. We can use a simple pendulum to represent the swing. What is the hypothesis to be tested? When the length of the pendulum increases, its period of oscillation increases. To test this, you need involved. To help you do this, you can ask yourself these questions. What do you change? Length of the string. What do you measure? Time for 10 oscillations. What do you keep the same? Mass of the pendulum bob, amplitude of oscillations. Based on the hypothesis and the variables discussed, you can set up a simple experiment to verify the hypothesis. The apparatus used for this experiment is shown above. How should they be set up? Before you proceed with the experiment, you need to take into account ways to reduce errors when making measurements. In this experiment, what are the possible source of errors? How can you reduce them? A possible source of error is the way the period of an oscillation is measured, and it can be reduced by allowing the pendulum to oscillate a few times before starting the stopwatch, taking the time for more than one oscillation, repeating the measurements, using a small angle of oscillation, maintaining the oscillation in one plane. Procedure. A simple pendulum of length 50 centimeters is set up as shown. The pendulum bob is pulled aside and then released to swing freely. The time for 10 oscillations is taken. The experiment is repeated for different lengths of the pendulum, that is, 45 centimeters, 40 centimeters, 35 centimeters, and 30 centimeters. How should you record the data? What would be the most suitable for this experiment? The data can be recorded in the form of a table. How should you present the data? What would be the most suitable for this experiment? The data can be presented in a graph. Let's now carry out the experiment. You can start the experiment by dragging the string to the retort stand. Click on the Start button to begin the experiment. You can repeat the experiment by clicking the Reset button. Based on the graph, what can you say about the relationship between time of oscillations and the length of the pendulum? The graph shows that the time of oscillation increases with the length of the pendulum. Does this agree with your hypothesis? Why should you write a report? A written report of your experiment will communicate to others what you investigated, how you carried out your investigation, and what you found out. The report can be used as a reference. Let us consider what should be in the report. Why was the experiment carried out? In other words, what was the aim of the experiment? To investigate whether the length of a pendulum affects the period of its oscillation. What was the hypothesis that was tested? When the length of the pendulum increases, the time of oscillation increases. What apparatus did you use and how was it set up? It is often easier to draw the experimental setup than to describe it. Retort stand with clamp, thread, pendulum bob, meter rule, stopwatch. How was the experiment carried out? Procedure. A simple pendulum of length 30.0 centimeters was set up as shown. The pendulum bob was pulled aside and then released to swing freely. Time for 10 oscillations was taken. The experiment was repeated for different lengths of the pendulum, that is, 35.0 centimeters, 40.0 centimeters, 45.0 centimeters, and 50.0 centimeters. The data was recorded in a table. A graph of time for 10 oscillations against length was plotted. How was the data recorded? How was the data presented? Were there any steps taken to reduce errors? Allowing the pendulum to oscillate a few times before starting the stopwatch. Taking the time for more than one oscillation. Repeating the measurements. Using a small angle of oscillation. Maintaining the oscillation in one plane. From the results of your experiment, what can you conclude? Conclusion. The time taken for 10 oscillations increases with the length of the pendulum. Therefore, the period of oscillation increases with the length of the pendulum. The hypothesis is accepted.